Hello friends, welcome back to our YouTube channel Doctor's Corner. Today we are going to discuss the part 4 of our ECG series. So in this particular lecture we are going to discuss about the unipolar limb leads. In the previous lecture we have discussed about bipolar limb leads. So today we are concentrating on the unipolar limb leads. So as you will be knowing that basically there are 12 leads in an ECG recording. So the 12 leads are 3 bipolar limb leads, 3 unipolar limb leads which are now known as augmented limb leads, and 6 unipolar chest leads or precordial leads. Okay, so you people already know that these limb leads, unipolar and the bipolar limb leads, they will record the electrical activity of the heart in the frontal plane. Okay, and the chest leads, that is the 6 precordial leads, they will record the electrical activity in the horizontal plane. Okay, so we'll discuss about the chest leads in the next section. We have already discussed what is mean by to be a lead, what are its connection and electrodes in the bipolar limb leads. So what are these unipolar limb leads and how many unipolar limb leads are there? So there are 3 unipolar limb leads which are designated as simply VR, VL and VF. Okay, so there is voltage in the right upper limb, voltage in the left upper limb, and the voltage in the left foot. Okay, but nowadays this is replaced by one more concept known as augmented unipolar limb lead. So nowadays this has become obsolete. Now we record the electrical activity, that is unipolar limb leads means this one, augmented unipolar limb leads AVR, AVL and AVF. So before going in detail about the unipolar limb leads, we should know what was the need of this unipolar limb leads and what is the difference. Main thing to understand is what is the main difference between a bipolar limb leads and unipolar limb leads, and why these limbs were introduced and all we'll discuss. Okay, so before that we'll just recollect what we have studied in the last class regarding the bipolar limb leads. Okay, what are exactly the bipolar limb leads? So quickly we'll revise that and we'll try to understand what's the difference between a bipolar and unipolar limb leads. Okay, so again I'll draw just a line diagram of a normal person and how the electrodes are placed, on which point the electrodes are placed. So consider this as the left upper limb and consider this as the right upper limb. Okay, and of course this is the left foot or the left lower limb and the right foot or the right lower limb. Okay, so we have totally bipolar limb leads, lead 1, lead 2 and lead 3. Okay, lead 1, lead 2 and lead 3. Okay, in detail we have discussed. Those who have missed that lecture, I request them please go to our playlist and check out for the videos of that ECG series part 3 of the bipolar limb leads. Okay, so basically in bipolar limb leads, what exactly happens or how the electrodes are placed on the surface of our body is, consider this as a galvanometer or an ECG machine. Okay, which has a pointer. Basically it's a galvanometer. It has 2 ends. So the positive terminal of the ECG machine is connected to the left upper limb, and when negative terminal is connected to the right upper limb, then the electrical difference, that is the recording of the heart. Okay, suppose heart is situated at the center here. So again a line diagram of a heart. So here the major ventricular depolarization vector, if we draw, that is the electrical activity of the ventricular depolarization, can be shown as the vector like this. Okay, we have discussed in detail how we get this vector and all in the previous videos. So basically the lead 1 records the potential difference at this point minus this, that is it has 2 bipolar limb leads. As now we are discussing about the bipolar limb leads. Okay, so bipolar limb leads, lead 1, 2 and 3. So lead 1 is the electrical activity it will record in this direction, that is the axis of this lead 1 is like this. What do you mean by the axis and all? So see, suppose this positive electrode is the camera or eye of a person, so if through this electrode we are recording the or seeing or watching the electrical activity of the heart, okay, so if it is recording the electrical activity of the heart in this axis, this is the axis of the lead, this is the axis or the vector, okay, cardiac vector. So this electrical activity, if we see through this point, okay, so it is basically recorded in this axis, that is in this axis if the eye is placed like this. Similarly for lead 2, for the lead 2, if we draw an ECG machine, so in an ECG machine, if the positive terminal is placed as the left foot and negative in the right upper limb, and positive is connected to ECG machine and again negative terminal ECG machine, the electrical activity which is recorded in this axis, okay, it is recorded in this axis, it is known as lead 2. So this is the electric lead 2 axis, that is eye or a camera is placed like this and it will record the electrical activity, and since it is parallel to the electrical activity of the heart, so it will generally record the normal ECG pattern in this way in the lead 2. So we have discussed in detail how exactly it will record like that, okay. Similarly for the lead 3, how the connection will be. So you know that basically the lead means it is the network of these wires and the electrical galvanometer here. So if we keep a positive electrode on the left foot and a negative electrode on the left upper limb, then we connect it to this ECG machine, and this will record the electrical activity in this axis, okay, in this axis. This is known as lead 3, okay, this is lead 1, this is lead 1, this is lead 2, and this is lead 3, okay. So together this lead 1, lead 2, lead 3, they form a triangle, a equilateral triangle, okay, that is known as Inthoven's triangle. We have discussed about the Inthoven's triangle and Inthoven's law in the last class. So again, why I am revising is to point out what do you mean by bipolar and what do you mean by unipolar limb lead, that is what is the difference and what is the need to introduce this form of limb leads, okay. So this is basically the bipolar limb leads, okay, lead 1, lead 2, lead 3. So lead 1 will record in this axis, lead 2 will record in this axis, lead 3. So again, when you record the electrical activity in the lead 3, so it is again of the same pattern, it will be recording in the same pattern, but only difference is the magnitude will be smaller than this one, that is the amplitude of that R wave and the other waves will be smaller. Similarly, because the lead, since it is this electrical activity, the axis is parallel, so it will record the highest amplitude. It is lesser further, this is also lesser because it is still farther the electrode, active electrode, which is visualizing the electrical activity. Again, it's not parallel, again it will be recording the same pattern, but still the height or the amplitude will be less. And according to Inthoven's law, if you add up or sum up the lead 1 and lead 2 potentials, that is the amplitude of this and this, it will be equal to lead 2, okay, that is Inthoven's law. We have discussed in detail in the last class. So this was the bipolar limb leads. Now in the year 1934, Wilson's proposed this unipolar limb leads. So what was the need of this? So you know, heart is a three-dimensional figure, okay. So we want to record the electrical activity from all the angles, okay. So these limb leads usually record the electrical activity in the frontal plane, okay, frontal plane means this up and down or right side and left side, okay. We'll discuss about the chest leads which will record electrical activity in horizontal plane, okay. So in the frontal plane also you can see. What do you mean by lead 2? Lead 2 in bipolar limb leads means it will record the electrical activity in this axis, that is like this direction. That is, if you keep a camera or a eye, so it will see the heart in this direction. Similarly, lead 3 will see the heart or electrical activity in this direction, and lead 1 will see the electrical activity in this direction, okay. Now suppose if I want to visualize the heart directly, that is if we keep it and directly like this perpendicular, okay, not in this direction, not in this direction, directly if I want to visualize the heart, Okay, similarly, if I keep electrode here, if I want to visualize the heart directly there at the point itself, the electrical activity, to visualize this directly, this limb leads, that is, to visualize means it means the recording the electrical activity at the point where the surface electrode is kept. Suppose if we keep the surface electrode here at that point itself, so to record the electrical activity, this unipolar limb leads was introduced by a person or a scientist known as Wilson. So it is also known as Wilson's limb lead. Okay, so in the year 1934 he introduced this term. So earlier in 1900 Inthorvans have discovered this bipolar limb leads. In 1934 Wilson has introduced this thing. So now what's the basic advantage of this is it can record directly, it can see the electrical activity for this. So for this, what was the drawback? Why can't this unipolar limb leads record directly? It can record in this axis or in this axis, because unipolar limb leads is positive and negative. So it's the potential difference between this positive electrode and the negative electrode. So it will visualize in this direction only. So suppose the Wilson wanted that negative terminal should be placed at the center only. So if he wanted to remove this from this side, because the electrical activity can be recorded from positive and negative, so he wanted to place the negative terminal at the center so that he can visualize directly. To make that negative terminal in the center, he proposed the concept of indifferent electrode. Okay, so what is that indifferent electrode? I'll just tell you or explain you. So I'll just erase this one bipolar limb lead system. So we will now directly concentrate on the unipolar limb leads. Okay, so hope this bipolar limb leads concept is clear. Now we'll discuss what do you mean by unipolar limb leads. So it doesn't mean that unipolar limb leads has only one pole. Bipolar has two poles. Definitely bipolar has two poles. Unipolar limb leads also have two poles, but there is some basic difference. Okay, so we'll discuss one by one. Okay, first thing is we'll discuss about the unipolar limb leads VR. What do you mean by that VR? That is the voltage at the right upper limb. Okay, then we will discuss about the VL, that is voltage, simply voltage, electrical voltage at the left upper limb, and VF, that is the electrical voltage and the left foot. Okay, so now the same Wilson's used the same Inthorvans triangle, but certain modification of this lead system. Okay, instead of this lead 1, lead 2, lead 3, he proposed these three leads: VR, VL and VF. VR, VL means voltage at the right upper limb, lower left upper limb and left foot. So how he modified is, for VR, while recording the VR, the same ECG machine, he introduced one positive electrode he kept on the right upper limb. Okay, now the negative electrode, instead of this negative electrode, he made this negative electrode as indifferent electrode. So what do you mean by that indifferent electrode is, he has connected one negative electrode to the left upper limb, then also he has connected the negative electrode, one more negative electrode he have with the wire, he has connected even to the right upper limb. Okay, this to the left upper limb, then right upper limb, then also he has connected one negative electrode to the left foot. So what Wilson's has done is, he created one indifferent electrode. Okay, one indifferent electrode and one exploring electrode. This positive electrode which is kept, it is known as exploring electrode, which will record the electrical activity at that point on which the surface, on which surface, that is the body surface, the electrode is placed. Okay, this is known as exploring electrode. And the another electrode, which was the negative in the bipolar limb lead system, in the unipolar system, that negative electrode is converted into indifferent electrode, or also known as null electrode or zero electrode. So what do you mean by that indifferent electrode? What he did was, he connected that negative terminals to not only to one limb, to all the limbs, left upper limb, right upper limb and left foot. So he connected the negative electrode in all the limbs, including the right upper limb also. Okay, so now what was the advantage of connecting that? So we have to use certain mathematics and some geometry or physics knowledge here. So in an volume conductor, if there is an equilateral triangle like Inthoven's triangle, okay, imaginary Inthoven triangle, and heart is at the center, that is the electrical source is at the center, and there is an equilateral triangle in a volume conductor, then the potential at the points of this is equal to 0. If you sum up the electrical activity of this, that is electrical potential, suppose at the left upper limb is VL, electrical potential in the right upper limb is VR, and the electrical potential in the left foot is VF, okay, VL, VR and VF, then the sum is equal to 0, or the average, if you divide by 3 also, it will be 0 at the center. So that is, this will act as a virtual electrode where the sum at the center will be 0, where the sum at the center will be 0, that is the left upper limb, right upper limb and the left foot, okay. So in an according to Wilson, VR, that is the VR is equal, the VR means that is the voltage in the right upper limb is equal to that is the one active electrode is placed, that is positive electrode, that is exploring electrode is on the right upper limb, and the negative electrodes is connected to the left upper limb, right upper limb and the left foot, okay. Now since the heart is not exactly at the center, and also it is not exactly an equilateral triangle, so they have put certain resistance also here along with that resistance. So now it has become a indifferent electrode, okay, that is the unipolar limb leads VR earlier, which was proposed by Wilson in the 1930s, that is 1934. Similarly, VL, for VL what he has done is he has kept a positive electrode on the left upper limb, positive electrode on the left upper limb, and the negative electrode, this negative electrode is made as indifferent electrode by connecting the negative terminal to the left upper limb, to the right upper limb and to the left foot, okay. So when we connect the negative terminals to all the other sides, left upper limb, right upper limb and left foot, along with certain resistance, why we have to put certain resistance or around 5000 ohms, why is because heart is not exactly at the center here, and this is not exactly an equilateral triangle. So if you keep it, so it will become a null electrode or indifferent electrode. So what does it mean by null electrode or indifferent electrode? That is, the potential recorded by this is 0. So basically the potential recorded by this indifferent electrode will be 0, and the actual current what you record at this point is recorded as the at the point, that is the VL, okay, this will be considered as VL. So in the VL, positive electrode is kept at the left upper limb and negative electrode is made as indifferent electrode. What do you mean by that is, if we keep the positive electrode here, and then the indifferent electrode will be here at the center, okay. Similarly, if we keep a positive electrode VF, okay, for VF, positive electrode here in the left foot, and the negative terminal is connected to the 3 limbs, that is the left upper limb, right upper limb and the left foot. So if we connect it and we connect it with the resistance, then it will become an indifferent electrode. So basically unipolar limb lead system has one exploring electrode, that is a positive electrode, and an indifferent electrode, which is the null electrode with the potential recorded by this is 0. And how it is achieved? By connecting the negative terminal to all the limbs, okay, all the limbs here. That is, so what is the science behind that is, if in a volume conductor in an equilateral triangle, if the electrical source is at the center, then the sum of the electrical activity at the points of the equilateral triangle or at the ends of the equilateral triangle will be 0, okay. That is virtually, we are making a virtual electrode. Indifferent electrode is a virtual electrode, that is at the center point. The indifferent electrode, it will be 0, and we are recording the electrical activity on this surface. So when we record this by this system, if we record VR means we will recording, that is the eye or a camera of this particular recording device is kept on the right upper limb, and it is recording electrical activity directly here, and VL also recording the electrical activity directly from this the axis is different. Okay, so the axis is different. To make this point more clear, how the axis of the lead, remember the axis of lead is different, the axis of the heart is different. So if we go to the Inthoven's triangle, if we take the axis of the bipolar limb lead, so limb lead 1, if we draw, so limb lead 1 will be like this straight. Okay, because it will record electrical activity like this from positive and negative end is like that. Limb lead 2, so the electrical activity is like this, and limb lead 3 basically it will be like this. Okay, limb lead 3 like this. So if we, this is known as triaxial system of, that is the axis of the bipolar limb leads. Okay, so this is the limb lead 1, limb lead 2 and limb lead 3. So limb lead 1, if we see negative, okay, negative from up, so it will be 0, minus 60, minus 120, minus 180, and here positive, plus 60, plus 120, like that. Okay, so this is the bipolar limb leads. So if we draw the axis of the unipolar limb leads VL, VR and VF, it will be like this. So VL means directly like this. Okay, so it is the axis will be like this and this will be 0, so directly to the point. So this is be VL, and VF will be exactly 90 degree. So this will be VF, and this will be again around 150 degree here, minus 150 degree. So this will be VR. So this is known as triaxial system of the axis of the limb leads. So what I have drawn with the blue color ink is the bipolar limb leads axis, and with this black color ink is unipolar axis. Okay, we will discuss about the axis and all, and axis deviation in the coming lectures. Just to make this difference between unipolar and bipolar, I have made this such detailed comparison. Okay, hope the point is very much clear. What do you mean by unipolar limb leads and what do you mean by bipolar limb leads? Okay, so unipolar limb leads are 3: VR, VL and VF. Okay, how they are created? There is one active or exploring electrode, it is the positive electrode, and negative electrode is made indifferent or zero by connecting it to the all these sides and by with a resistance. Okay, so limb leads unipolar VR, VL, VF. Okay, so with the help of this it was able to, we were able to record it directly on the surface. Okay, directly the electrical activity was recorded. For example, VL, VF and all, we used to record that P wave, QRS complex and T wave, everything was recorded. But there was one disadvantage by with this Wilson's unipolar limb leads. What was the disadvantage was the size or the amplitude of the current recorded was very much minimal, because the indifferent electrode was at the center only. So the electrical activity which was recorded was of very low amplitude, and what we are getting in the graph was very smaller waves. Okay, very smaller waves as compared to the limb lead 2, 3 and 1 of bipolar. So because of this drawback, it was of smaller amplitude. Then later one more person, Goldberger, okay, Goldberger in 1940s. So what he did was he proposed this one, AVR, AVL, AVF, that is modified unipolar limb lead. So just he modified the concept of Wilson. First scientist was Inthoven's, who discovered the bipolar limb leads 1, 2, 3. So by using the same Inthoven's triangle and all, he modified and made the unipolar limb leads VR, VL, VF in 1934. That is this one, it is called as Wilson's common terminal. That is, he made, instead of two poles, the one pole was active and another was indifferent. It is known as Wilson's common terminal. Now the drawback of this was the current amplitude was less. This drawback corrected by Goldberger, he modified this, it is, and named them as augmented unipolar limb leads. Same Wilson's unipolar limb leads, he now augmented. So nowadays these are obsolete, only we use this one, this limb leads, modified Wilson, that is the augmented unipolar limb leads, AVR, AVL and AVF. Now what is this augmented? So basic idea of augmented limb lead is, augmented means magnified. Here the magnitude is magnified around 1.5 times. So how the magnitude, everything is same, but how the magnitude was thing. So instead of this virtual electrode at the center, they kept the virtual electrode here, and the magnitude of the current recorded was of higher degree. Okay, so it was higher degree, and the waves was like this in augmented limb leads. Okay, so how what changes he did to this lead system is, so what was the basic drawback was, so here because of this negative terminal, since it is connected to all the three limbs including the right upper limb also, what he did was, the same Wilson's unipolar limb lead, he disconnected this negative terminal from the right upper limb. So he kept one active electrode, that is the positive electrode, on the right upper limb, and kept the negative electrode in the left upper limb and the left foot, but he removed the negative terminal from the right upper limb. So by removing this, the cancellation of the current was removed and the magnitude was increased. Okay, similarly for the VL, the positive electrode is kept on the left upper limb and this negative electrode is kept on the right upper limb and the left foot. He removed this one, he removed the negative electrode from this. So basically in the AVF, now this is called as AVL and now this is called as AVR. Okay, so in AVL, positive electrode in the left foot and negative electrode in the left foot and right upper limb. Similarly for AVF, positive electrode in the left foot and negative electrode is placed in the right upper limb and left upper limb, and he removed this negative electrode which was there on the left foot. So in augmented limb leads, one of this is removed, and of course the same thing was achieved because there was a resistance was there, so it is removed, this was removed and this was removed. So in the AVF, now AVF, what is this augmented AVF? The positive electrodes in the left foot and negative is present in the left upper limb and right upper limb. Negative from the left foot was removed now. Okay, so because of this, now it is magnified and AVR, AVL and AVF, that is augmented limb leads, are introduced by the Goldberger in 1940s. Okay, now we want to see the pattern of this. Now see, in AVF, since it is recording the electrical activity in this direction and the positive or exploring electrode, that is the eye or the camera, is placed here, so it will record a positive deflection like this because the current is flowing towards the recording device. Similarly in the AVL, it will again record the positive deflection wave. Okay, it will record the positive deflection wave because the current is flowing towards in this direction of the recording, this one. But in AVR, this current is flowing in the opposite direction of the exploring electrode because it is the direction of the exploring electrode or the camera or the eye situated here, and the electrical current is moving in the opposite direction. That's why we get the negative waves. Okay, we get the negative wave and it is absolutely normal in an ECG. The R wave, QRS complex R wave, will be negative here in a AVR lead. Okay, so when you see this ECG, normal ECG pattern, you see that it is negative in the AVR and it is positive, the pattern is positive in the AVF and AVL. Why it is negative is because the recording device is here and the electrical current is moving in the opposite direction. So what is the basic science of recording in ECG is, if the electrical current is flowing towards the recording device or towards the positive electrode, then it is positive deflection. If the electric current is moving in the opposite direction of the recording device or the positive electrode, then it is negative deflection. Okay, the same thing we have discussed in the first class. Okay, so that's all about the unipolar limb leads. So hope the concept of AVR, AVL and AVF is clear. So let me just summarize this. So unipolar, nowadays unipolar limb leads means AVR, AVL and AVF only, augmented. So in AVR, active electrode or exploring electrode is placed on the positive electrode on the right upper limb, and indifferent electrode is created by placing a negative electrode in the left upper limb and left foot. In AVF, active electrode is placed on the right upper limb and negative electrodes are placed on the right upper and left upper limb. In AVL, active electrode is placed on the left upper limb and negative electrode is placed with resistance in the right upper limb and the left foot. Okay, so this is all about the augmented limb leads. Thank you very much, and in the next lecture we'll discuss about the unipolar chest leads.